You know, the pesticide, normally it's a chemical, and that chemical needs to be in a certain form so that it reaches its target. So this is what I am going to talk about. It's like preparing a meal, food. There are different formats of presenting it. Some may be in the liquid state. Are we together? Hello?
Yes,
Hello,
Doc.
Doc.
Yeah, this is what I am going to talk about. It's like I'm going to talk about food, which can be presented in different forms. So these pesticides can be presented in different forms. They can be liquids, solids, and so on, or even gases. So our topic is pesticide formulations. I'm sure you've purchased some pesticides from hardwares. It's either they are liquids or solids, depending on the pesticide. So what is formulation of a pesticide? It is the form in which the pesticide is sold for use. Now, the pesticide actually consists of basically two things. Number one, it consists of the active ingredient. That is the poison which is going to kill the pest. And it is also packaged with innate materials. You can have what we call the concentrate, which is part of the total formulation made up of the active ingredient expressed as a percentage of weight and is normally stated on the label. So the concentrate is mostly referring to the active ingredient. Now, what are the common formulations? Pesticides can be presented as liquids. In fact, you can buy them from the hardware or shops as liquids, or you can buy them as solids. Now, I've talked about the active ingredient. That is the pesticide which will kill the pest. But during packaging, we also have other materials, which we call innate materials, which are part and parcel of the pesticide. So what are innate materials? You can have what are known as adjuvants. Adjuvants are additives in low amounts that improve or enhances storage or handling of active ingredients. So that is the purpose of the adjuvants. They facilitate handling of pesticides. You can also have what are known as surfactants. These are spreaders or stickers, emulsifiers, or wetting agents. Later, we'll explain what they are or what is their purpose in a bit more detail. You can have a pesticide mixed with anti-drift agents. Probably that is self-explanatory. That is self-explanatory. Some agents can stop drift. You can also have some colors or odor additives, which can discourage people from eating this. So you put an odor to give a signal that this is a dangerous liquid. In some countries where low temperatures can affect spraying, you put antifreeze or other stabilizing chemicals to promote storage. So you put something so that when there are low temperatures, your pesticide is not going to freeze. Now, active ingredient is the poison. So these poisons or active ingredients have to be delivered in various formulations. Basically, we can put 4 categories of the types of pesticide formulations. Number 1, we could have solutions. A pesticide in the form of a solution. It can be in the form of emulsions. We may have dry formulation suspensions, or we could simply have granules. This is the broad classification of formulations. Now let us look at the pesticide which is formulated as a solution or water-soluble concentrate and soluble powder. So you can have a water-soluble concentrate, or you could have a soluble powder. What it means is that the concentrate or the powder can easily be dissolved in water to form a true solution. We have some herbicides which are formulated as soluble concentrate, and on the label it is written SC. If it is soluble powder, it's written SP. If it is soluble liquid, it's written SL. So you could have, if you look at the pesticide labels, normally you can get some of these symbols. By the way, water is the carrier. We normally use it to deliver the pesticide, or we can mix water and the pesticide. Then we spray. We can have herbicides like amine or ammonium salt or mineral salt. so that it can easily dissolve in water. We can also have what is known as agitation. It's a mechanism for mixing inside the tank. This one may not be necessary if you have SC and SP solutions, because these are easily dissolved in water. For example, we can have a herbicide solution of arsenal, Roundup, and the Todon. These are easily made into solutions using water. So one of the formulations is that you have a form like soluble powder or soluble concentrate, which can easily make solutions. On the label, like this one for glyphosate, SL, it means soluble liquid. In any case, glyphosate is applied as liquid. And when you mix it with water, it can easily form a solution. There could be other pesticides with this sign. It means that you can easily make a solution using that pesticide. Again, this is a glyphosate. Right. I have also paraquat. You can see there's this SR, meaning that you can easily mix paraquat and water and make a solution. That's what it means. You could have this on a fungicide or on an insecticide. SR means that the liquid in that container can easily mix with water. Okay, it's the same thing as SR. This is Basagran again, referring to SR. Of course, you could have an SE soluble. You could have an SE. Let me go back a bit. Sorry, an SC. So this is the one which we were talking about, SR, which was I was giving the examples. There could be an SP soluble powder, which means that powder can easily form a solution. SC, it could be a concentrate, which can easily make a solution. So these three refers to formulations which can easily make solutions. If you take the pesticide and mix it with the water, it forms a white stuff with a milky appearance. That is an emulsion. If you just mix it with water, something white turns up in the container. They say emulsions are like chemical bridges between droplets of oil and the body of water. If you want to look at the chemistry of the mixture, you have linear molecules with hydrophilic, that is water-loving head, and lipophilic or oil-loving tail. That is when you want to understand the chemistry of these materials. Now, when oil and water are mixed, they congregated the interface between the two liquids. And the mixture gives this milky appearance. Note that growth regulator herbicides may form, they are formulated as esters. Growth regulator herbicides are things like 2,4-D. And if you mix them with water, sometimes they give you this whitish appearance. So emulsions or emulsifiable concentrates can be used to deliver pesticides. Now, on the label, you can see it is written EC, meaning emulsifiable concentrate. If you mix the liquid from this container with water, expect a whitish stuff which looks like milk. Another pesticide with EC, meaning emulsifiable concentrate. This is alacro herbicide. Again, look at this EC, emulsifiable concentrate. Another chemical again with EC, emulsifiable concentrate. Probably you have heard about Agil. I think it's the herbicide which can be used to kill grasses in groundnuts. It has this EC. So if you see EC on the container, it means emulsifiable concentrate. Now we're moving on to liquid flowable or liquid suspension formulations. From my experience, when you are dealing with the liquid flowable, these are very difficult to use sometimes. If you want to measure, let's say you want to pour them in a measuring cylinder, it can be messy. It can be a messy job because they are not easily poured in the measuring cylinders. By the way, when you are measuring, when you are entering these, you need the gloves. So liquid flowable or liquid suspension formulations, these formulations are highly viscous. They are not easily poured like what I've mentioned. That is their problem. You have a slurry or a porridge-like stuff in the container, which is a paste formed by wettable powder and water. So it's like a porridge thing or a slurry. Now, the liquid flowables can separate during storage. The big particles settle on the bottom, and you have the fluid on settling on the top. So before you use such a pesticide, you really need to shake the container to make sure that everything is mixed. So you require careful remixing before use. And as I have said, it's very difficult to use these ones. A liquid flowable or liquid suspension formulations. Here we've got atrazine, which has been written flowable. That's what it means. It means even if you try to pour atrazine, it's difficult. It can be written FW in short, referring to flowable. Again, we have 500 FW, meaning flowable. Again, Gadomir, 500 FW, meaning flowable. So you know what to expect if you have FW. Expect some problems during pouring. Geyser packs also FW. Now I'm going to talk about dry formulations. You can have the pesticide presented as granule. It looks like fertilizer granules. This is ready to use mixture of a small amount of active ingredient with innate carriers. So the pesticide is actually absorbed in the granule. This could be used for soil treatment. The good thing about granules is that you may not need to mix them with water. And it also minimizes drift when you are applying granules. And they are ready to use. But the downside of granules is that they are heavy. Large quantities may require expensive transport. Yeah, in Zimbabwe, we used to have atrazine, which was in the form of granule. Farmers didn't need a sprayer. So you could just broadcast the herbicide using your hands. In terms of safety, sometimes granules, are safe to handle. From granules, you could have pellets. They are similar to granules, but I think these ones are a bit bigger in size. They could be applied by hand or machines. They are also used for soil treatment, drift. If there's wind, a lot of wind, this is not a problem. And usually there's reduced the application hazard. Some of the rat poisons, are in the form of pellets. If you wanted to kill some rats, when you buy the rodenticide, it's in the form of pellets. Now we move on to wettable powder, WP or W. From my experience, I don't like these pesticides, which are in the form of powders, You really need a mask when handling these. Otherwise, wind can easily blow the stuff into your face. You could have finely ground solids, mineral clays containing active ingredients. So the active ingredients are contained in the clay particles. And dry formulations in the form of wettable powders, WP or W, they are in the form of dust. This is why you really need a mask. I think these are the most dangerous pesticides. It's very difficult to handle them. In most cases, you see a lot of people coughing when they are handling these dusty pesticides. Now, wettable powders can form suspensions in water and form true solutions. But you need to constantly shake or agitate the container so that they are in the solution form. But one of the disadvantages is that some particles are abrasive, so they damage pumps and nozzles. That is one of the problems using wettable powders. During mixing, now it's a problem. You can inhale, the dust. So you really need a mask. So there's inhalation hazard during mixing. These are not good formulations for pesticides. I think they can expose workers, to serious danger. Yes, a pesticide tribunal, 70% WP or powder. We also have Sengo, which was sold as WP. At some point, atrazine also was sold as WP, but nowadays we have FWs, the flowables. Iron also WP. We move on to soluble powder, SP. These form true solutions. You don't necessarily need to stir or agitate the container. It may not be necessary. These do not damage the equipment. They are not abrasive like wettable powders. Wettable powders are notorious for damaging equipment. The hazard to inhale the dust is there, so one needs a mask. We move on to what is known as the water dispersible granule, WDG, water dispersible granule, or it's known as DF, dry flowable. The water dispersible granule or the dry flowable can be mixed with water. These can readily disperse in water to form a suspension. So constant agitation is required. But the good thing about water dispersible granule or dry flowable, DF, is that this is not a dust. So there is no inhalation hazard, you know. Of course, you need a mask. The disadvantage is that it can damage equipment because it's abrasive. We've got two herbicides which are formulated as one. We have diuron, which is formulated as DF, dry flowable. We have got nicosulfuron, which kills chamfer grass in maize, is sold as a granule, as WDG, water dispersible granule. Here I'm going to talk about the additions which can accompany the active ingredients, which can be part of the formulations. What we call spray adjuvants, additives. These are surfactants. This could be added to improve herbicide efficacy or any other pesticide efficacy. We have activators, which can improve pesticide efficacy after the spray has contacted the leaf surface. There are also utility adjuvants, which can improve the ability to get the pesticide to the leaf surface. So they just aid the pesticide either to remain on the target or to penetrate the target. Now, the activator adjuvants, these are water. Let me talk about the properties of water so that we can understand their effect. Water is a polar molecule with negative and positive charges. You know, water contains oxygen, which carries the negative charge, and there are two hydrogen atoms attached to oxygen, and these hydrogen atoms form positive charges. Because of these charges, water molecules are strongly attracted to each other than the surfaces they are in contact with. Therefore, if you use water as a media to deliver your pesticides, water tends to run off from the target surfaces, which means it can go with the pesticide where it is not wanted. That's why you need the activator adjuvants. You also need wetting agents, which can actually reduce the surface tension or the attraction of the water molecules to each other, so that they can stick to molecules of other substances. So if you put a wetting agents, you reduce surface tension, you make the droplet stick to the surface of the target. It could be the target pest. Surfactants can be soap. Here, I've just used the soap as an example of surfactants because it has got these charges. It can be attracted to the water and break the surface tension. We just want to explain that the surfactant could be charged so that it can easily mix with water. What is interesting is this, where we have a droplet with a little small surface area in contact with the target, and it can easily roll off with the pesticide. But if we put a surfactant, we can flatten this point of contact, and there's a chance that the pesticide can enter the target. We also have stickers. These help the pesticide to stay on the leaf surface after water has evaporated. The herbicide or pesticide can efficiently be absorbed if you have stickers. We also have what are known as humectants. Usually, because our pesticide is delivered by water media, water can easily evaporate and leave the pesticide, and that pesticide residue may not penetrate the target. So humectants retains moisture or absorbs water vapor. It can reduce evaporation, and it can prevent the herbicide from crystallizing or pesticide from forming a solid substance which cannot penetrate the target. Now, this can actually increase absorption of the herbicide into the leaf, or it could be any other pesticide in the leaf. So humectants, if they are formulated together with the pesticides, can enable efficient absorption. Some are self-explanatory. Penetrants. You know, the plant has got a protection, which is the cuticle, a waxy cuticle. So you may need a penetrant which will dissolve that cuticle. So you need an oil-soluble penetrating agent which allows the cuticle to be broken so that the pesticide can enter the plant. You may also want it to control drift. So how do you do it? Because small droplets can easily be carried by the wind. So you may mix your pesticide with long chain molecules. These are substances which are going to probably make the droplets heavy. And this can stop drift. We know sometimes when we are mixing pesticides, especially if you are handling glyphosate, it will form, you know, there's the foam which is created. It's a white stuff during spraying. You know, the problems with this foam, especially when you are mixing, it becomes very difficult to measure accurately the volumes which are required. Because you may think you have got the herbicide, yet it's just the foam. So a substance called a deformer can be mixed with a pesticide so that you reduce this problem. We can also add what are known as colorants to the pesticide. This helps to increase visibility of the spray so that when someone is spraying, you can actually visualize the droplets, where they are going. And you can see the spray pattern when you are spraying. This is just for visibility. It will enable those who are putting the herbicides to target the pest properly. So this is it on the pesticide formulations. So I will stop presenting. Hello? Hello?
Yes, Doc.
Oh, yeah, okay.
Doc.
On the formulations, we've said that we have got these pesticides, but they have to be presented in a certain formulation. We know the pesticide is the active ingredient, but it has to be packaged in a way that when using the pesticide, it doesn't give us problems. So we have got various ways of packaging the pesticides, depending on what we want to do. I can give you an example of, let's say you've got rats in your house. Would you take a knapsack sprayer and start spraying?
No.
Because if you start using a knapsack sprayer, you may end up spraying
It's not
places which are
possible.
not supposed to be sprayed. So you don't need a liquid, you may not need liquid formulations, but you now need dry formulations. The best approach with the rats is that you use pellets, isn't it? You can put pellets in a container, place them somewhere where children may not reach, so that you target your rats. So that is where you can, I don't know, if you have cockroaches, sometimes you can use something which sticks to the cupboards and so forth. So this is about formulation and how it can help us to deliver the pesticides. And if you have got a cotton, cotton plant, and you want to kill insects under the leaf, maybe this is where you need liquid formulations. Do you have any questions on the formulations of pesticides?
No, Doc.
I think for today we will stop here. Then I don't know, when am I meeting you next? Tomorrow?
Yes, Doc.
Yeah, tomorrow, what time do you want us to meet?
I think from 2.
From 2 o'clock, okay. What is going to happen tomorrow is that I may attend a meeting, and I would like to believe that it may end up at 3. So I may start the lecture at 3 o'clock.
It's okay.
Yeah. Anyway, I will be informing you as we progress tomorrow.
Okay, Doc.
In the morning, it's difficult, is it?
Yeah, mornings
it's
are
difficult in
difficult
the morning.
with work.
Yes, for me, I'll be
Yeah, you
having
just give
classes.
me the slot. Yeah, you just give me the slot where you are comfortable, so that all of us can be there.
Okay.
No, that's fine, Doc.
Yeah, I can even do it during the night if you want.
Yeah. If the others are available, it's okay with me.
It's okay.
Yeah. So what I will do, I'm going to post something, or I mean, it's a sort of an assignment on what we have done so far. I'm doing it, right?
Yes, Doc.
Yeah, don't write a book about it.
Okay.
Yeah.
Isaac, usanyora book show.
I know I want.
Okay, so what I will be giving you after each lecture will help with the revision as well. So after each lecture, I will post something. After each lecture, I will post something.
Okay, Doc.
Okay.
Yeah, goodbye.
Bye. I will send you the recorded